Dr. S. Abdul Majid, and Mr. S. V. Mohammed Hanif. Chancellors. Now I invite our esteemed Dr. S. A. Shahul Hamid Sir, Director, Aquatic Animal Health Laboratory, C. Abdul Hakim College, to deliver the presidential address, sharing the vision behind this initiative and the importance of encouraging research culture at the grassroots level.
Of the very important program for voting the students as a future scientists of the country. Again, I welcome you all for this program from different schools, from different colleges. We are going to have a very responsible job. Even can say it's a great service because after attending this workshop, we are going to mold our students as the future scientists of the country. You may be knowing that the importance of the scientists in the country. So we are very lag behind having number of scientists in India. Whichever countries having more scientists, that will be the developed countries, like USA, China, Israel. So wherever more scientists are there, that can say that they are rich in economy, they have the developed problem in their various aspects. So because of the importance of the scientists in the country, we are conducting this kind of program at school level and college level. So every program is supported by the state government as well as the government of India. See, if you ask any of the school students just to name the scientist name, any of the name of any of the scientists, definitely they will say not Abdul Kalam. So we need the scientists like Abdul Kalam in the field of space research. We need the scientists like U.S. in the field of agriculture. Still, we are lacking. We don't have a replacement of Abdul Kalam in different fields. Still, we are lacking good scientists in medical science. We need more scientists in the medical science, agriculture, as well as environment. See, I have been doing research for the past 40 years. I developed the tendency of doing research when I was doing my embassy project. After completing my embassy project, I developed the tendency of doing research. I love the research. Still, I am doing research after my interview. So I got the chance to have the research attitude when I was doing my MSc. But now, even we have the same kind of research attitude at the school level because of new people. So you have a very responsible job. So you have to mold or you have to develop the research attitude at the school level. So then really we get more scientists in future for our country. See, when I developed that research attitude, then I continued my PhD and BSc, doing research. So all kind of research activities are supported by the government of India. So we have sufficient amount for research purpose. So we have a lot of grant for different funding agencies. For example, for biological science or in chemical science, physical science, whatever the science it be. So we had different funding agencies like Department of Science and Technology that fund for the projects different field, including life science. So we have separate department under Government of India for biotechnological science, is the Department of Biotechnology. So how many of you know how much grant is available in the Department of Biotechnology? So we have 10,000 crore for every year in the field of Department of Biotechnology. How many people are using it, that money? Very few people. So I have been a member of the Department of Biotechnology for the past 15 years. But still, I'm getting the project, less number of project from government, from Tamil Nadu state. So whatever that getting project from Tamil Nadu, just I'm giving the support to them, not fully, but whatever the eligible project we are supporting. So, so we are responsible for developing more scientists for our country. So that is a very good chance for you to help the student, to identify the students having some research attitude that will mold the particular students. As a student, as a scientist, I'm anyhow there are the presenters are there. We are going to give a detailed things how to prepare the project proposal or scientific project. So in addition to that, I give some points how to help the student to develop the research attitude or develop the science project of the student. Still, we have only 5 minutes time for our address. Just I give small some points. Before any after attending this workshop, we are going to the school or colleges just to identify the maybe every class may be having the 50 students or 60 students. Just to find out maybe one student or group of students having some research attitude. Definitely they will be having it. To select that particular kind of students, to take them to any of the research institutes or research laboratories. So we have the wonderful research laboratories on all the facilities that we are doing research of international standard. Even we are very happy to welcome you for our laboratory, there's no doubt. Even after completing the workshop, you can visit our lab. Even you can also bring your students to our lab just to see what are things we are going to do. We are doing it. So to take the students from research institutes or research laboratory, ask them to interact with the scientists there. So they may have some ideas. So after going to the schools, just to discuss with your students what kind of ideas they have. They may be the biological science or physical science or mathematical science, whatever it is. Just you ask the ideas, then after that, ask them to prepare a small kind of some scientific project. Just to see that whether the project is feasible or not, whether that can be done here or with the available resources. Some people, some students will say that I am going to do this, maybe big, not just to see the with the students. Ask them to collect some references. That all you help them. See, these are all the things we are doing it when we are after completing my MSc. Just to teach them at the school level. So collect the references. You help them how to collect the references. Ask them to design the experiment with available materials, with available equipments in the school or college, whatever it is. Then ask them to conduct some experiments. How to conduct the experiment, how to conduct the test. See that the test or whatever it is doing it, having a consistent result. Sometimes one test will be failure, other test will be success. So we should get the consistent result. Ask them to interpret the result, prepare the report, make a model. That model should be exhibited in the exhibition. Train the students how to explain to the audience. This is just train them how to answer who are asking the questions about the project. So these are the way you have to help the students. Teach them what are the ethical issues faced by the researchers. Now, before there is no issue at all from the ethical side. Now the researchers are facing a lot of problems from the ethical issues. That may be the animal ethical issue or biosafety issue. Just to train them how to handle the animal and use the animal here. So there are so many protocols to handle the animals. That comes under animal ethical community. Suppose the fellow is using some chemical substance, what are the precautions to be taken as a safety measure? That also comes under biosafety community. So these are what teach them in the school level. So definitely these are the things will be helpful for the developing the scientific attitude and also they become the science in the future. So these are the things I want to share. So really I'm congratulating you for accepting this program. So please listen to them. So we have the eminent personality from the USA. Really I'm very happy that you are doing research by medical science is very, very rare. So I have met with thousands of scientists in my research career. I found only 2 or 3 scientists with medical background. So really, they are very happy to have a person, scientist, with medical background doing research. Really, it's very surprised. So most of the medical people will go for only for practicing and getting the money. Very rarely some people do the research. Even my son is also a doctor. I so many times he asked him to go for research. He never. So these are the tendencies that all our medical people are having. So really, we are having so many personalities for presenting that how to prepare proposed project proposal. So make use of them, we listen to them, and we help the students for developing the scientists for our country. Thank you.
Thank you, sir, for your motivating and insightful address. Let us now move on to the core part of today's event, the technical session. The first technical session is titled Significance of Science and Engineering Methods in Innovation and will be conducted by our Chief Resource Person. We are honored to have us today a distinguished academician and guide, our Chief Resource Person, who brings rich experience and deep insight into science project monitoring. I now request Dr. Qazi S. Azhar, sir, Associate Professor, Michigan University, USA. Over to you, sir.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم رب اشرح لي صدري ويسر لي أمري يفقهوا قولي الحمد لله رب العالمين الصلاة والسلام على رسوله الكريم Honorable Chairman of the Constitution, Dr. K. scientist, I came to know, and Dr. Nazir Ahmad Sahab, my, I should say, old friend, young friend, Vice President of OMIA, Dr. Nazir Ahmad Sahab, Nazir Ahmad Sahab, Dr. Nazir Sahab, and my right hand when it comes to Tamil Nadu science fair activities. And similarly, Samit Raja, Madam, she's young but well experienced in science fair, and inshallah in future, when teachers like her will join the science fair, at one time we want to retire and do carry this flag of science fair. Similarly, there are other Dr. Abdul Majid Sahab, Dr. Mr. Muhammad Hanif Shah, he also for a long time with us as in National Science Fair. So with all that, I would like to start. I usually move around if you would give me the wireless. Thank you very much. I think there are a lot of teachers, lecturers, professors. Sadhya, did I recognize you? Thank you very much for all what you did. One thing we should notice, since we got independence, when India got independence, we did not produce a single Nobel laureate. Sir C.P. Raman, he got the Nobel Prize in 1930. Before that, nobody mentioned about this person. But he was born here. And he discovered malarial parasite. Who is that? This will be an interactive session. Who was that? Little louder. Ross, you said Ross? No. Ronald Ross. 1950. After freedom, we should have free thoughts, different innovative thoughts coming to our mind, but he did not. The only thing which happened after independence, we started English medium schools. Science doesn't mean that you have to know English. In Tamil, in your mother tongue, you can be very innovative. Better than US, better than Canada. Even Finland, with 5.5 million population, they have great scientists. What is happening to us? We have to think about it. There are only two professions. Our Indians are geared towards that. What are those two professions? Medicine first, then engineering. And Alhamdulillah, we have a lot of engineering colleges. I want to tell you one thing. The definition of engineering and science. I see you have opened your notebooks. Science means discovery. We said DNA is discovered. We don't say Earth is discovered. I'm going to the part so that everybody can understand. First of all, I'm very sorry I cannot speak Tamil. I love to speak your mother tongue so that it goes right in your head. English is foreign language, even though I'm speaking English. But I don't hate English, but I promote mother tongue because as Ma'am Nazir Sahab mentioned, that I'm also educationist. I get every month more magazines in education than in my own field, medicine. And I feel sorry to see our mother tongues are dying in India. I don't know what craze is this. You ask any teachers here whose mother tongue is Tamil. They all, most of them, about 80% of them send their kids to English medium school. Why? Why you are killing your language, your identity, your civilization, and your scientific mind always comes through the mother tongue. Why not in United States? If Germans are better, why don't they have Germany schools? Germany medium schools. They don't have. But we are crazy people. Why I am saying this, one of the number one reason why we are not producing enough scientists in our country is because we have an inferiority complex with our own language. You know, I studied in Urdu medium. I love science. Why? Because I understood science. The same way science is discovery. I will fluctuate from here and there. This is the technique we adopt to keep your concentration. When I will talk about education, I was talking about the last 2 weeks in different schools, and in fact, I gave about my talk about medium of instruction to English medium teachers. Teach your kids in mother tongue. And they were all Hijabis like you, mashallah. Very nice. One way we are showing our attachment to the religion, whatever religion is. I don't discriminate the Christian, if you are Hindu, if you are Muslim, I don't discriminate. Scientists never discriminate based on religion. If COVID vaccine comes, it comes for Muslim, it comes for Christian, it comes for Hindus. There is no discrimination. Remember this. Science is for all. So science is discovery. And then engineering. Very unfortunate again. Engineering means invention. Engineering means inventions. How many engineering colleges we have in India? How many scientists globally recognized we have produced? Not a single one. IIT. We talk about IIT, don't we? Everybody give exams to get admitted in IIT. I'm not trying to discourage you to go to IIT. But look at the fact. How many inventions came from IIT? How many? How many Nobel laureates came from IIT? What is the number of, in the world, what is the rank IIT has in the world? Surprise, not even 200. Isn't it sad? Don't we have to think about it? What kind of generation we are producing? I was, Uber. I called Uber and this driver came. I asked him, what are you doing? He was speaking good English. So I thought he's well educated. So I said, what's your qualification? He said, he's engineer. I said, why are you in a taxi cab? Why are you a driver of a taxi cab? The answer was, I didn't get a job and I'm making more money per month, almost a lakh, than I would have my professional engineering job. 10,000, 15,000 the most. What are we doing? Think about it. Sometimes, every time I come, what is happening to our brain? Our brain leaking. Believe me, the same brain, same genes, when come to the United States, they win Nobel Prize. Why not here? Because we have an inferiority complex. We are so mesmerized with English. Don't have to worry about it. When Dr. Hamid, when you are doing research, I'm sure he is not thinking in English, he is thinking in his mother tongue. I'm telling you, it's okay. In colleges, you can learn, but the basic knowledge should be in the mother tongue. I will give you an example. I will talk about the engineering method and scientific method, and I think Samin Raja, Madam, you are going to talk about the scientific method and the exhibition, the difference between exhibition. So I'm going to leave that part to Samin Raja, Madam. Dr. Nazar also gave a lot of good presentations, and today it looks like we are giving you rest. Thank you. So, little bit warm. I'm going to take off my jacket, but don't worry. The brain is still the same. Okay. So, engineering method. Sometimes my presentations, seminars, workshops are sponsored by Jana Vijnana Vedika. It's a national organization, and Ramesh was the secretary in Hyderabad, and Telangana. I asked him, go to all the engineering colleges and find out how many lecturers, professors, students know about engineering method. Click. You can write down engineering method. Engineering means invention. He came back with the data. He said not a single professor or student knew about engineering method. Isn't it pitiful? We don't. If you go to United States and pull out fourth grade book of science, fourth grade book of science, the first lesson will be how scientists work. A little higher grade, what is scientific method? They will give you examples. They talk about what are variables. Dr. Nazar loved to talk about variables, independent variable, dependent variable, and the constant variable. What is the control in the experiment? How many of the students, our students, know about this? You ask a fourth grader, a student in the fourth class will tell you all about this. That means they train their students while they are young. That's why they win Nobel Prize. I was telling about IIT. We hype up IIT so much, but inside nothing. MIT, IIT. MIT means Massachusetts Institute of Technology. Where is that? In the USA. At least you have this much general knowledge. That's great. You know how many Nobel laureates came from that institution? Yes. More than 100, and they keep coming. More than 100 from a single institution of engineering in United States. Isn't it good? Yes, it is good. Whatever they are inventing for the whole world. When submarine is invented, it was invented for the whole world. When aeroplane was invented, it was invented for the whole world. But somebody is making money out of that. Why not India? Why we have to buy Rafale from France? And we have 1.4 billion people. And they have brain to invent such. We should exceed their inventions. We should come up with more and more advanced technology. Why we are not doing this? What are these engineering, thousands of engineering colleges are doing in this country? Why we are sending our kids to IIT and paying so much money and all that? And see, the problem is, right from the beginning, as I said, fourth grader, we will talk about what are the steps in scientific method. And by the way, scientific method was invented by whom? No. Who invented scientific method? No. How much money I should pay to give the answer? Who invented scientific method? What we do? Complete the syllabus. In education, this is what we do. But would you do science fair? No, we do not have time. Oh, we are overwhelmed with a lot of work. Government gives us work, as if every day is census work. No, we have to put down everything. We have to wait the plan and up. Forget about it. Americans are doing more work than you. Because we don't want to see our kids as a scientist. You know, you tell me who. It has helped them. But you know it, I'm not going to give you money. Ibnul Haydar, in Latin, Al-Hazar, A-L-H-A-Z-A-N. If you Google it, you will get it. Encyclopedia Britannica says Al-Haytham is the first scientist. Haytham is the first scientist. He was father of optics. I am seeing your faces clearly because of these lenses which I have. They are concave lenses. He was the one who developed concave lenses, convex lenses, and pinhole camera. You know the camera. He invented that. And all the laws of refraction and reflection, all, found out by, what was his name I said? Al-Haytham. Good. So now talk about engineering method. I will do a little difference between engineering method and scientific method. When you look around with your observation, you come up with some question or a curiosity-based question. It is called scientific question. For example, when Mendel was experimenting, Mendel's law, everybody knows, because we memorize all the laws and principles without understanding it. Mother wrote nothing. Look at it. He said that there are red flowers, white flowers. But I also see some flowers which have red and white both. He said there is a transfer of genetic material. So this transfer of genetic material we found out. And he said that there are dominant alleles, there are recessive. One which is suppressed. This he discovered. The question was, what was the question? Very good. And now we have the mixed. And then the experimentation. He took the pollen of the white flower and the red flower and exchanged, transferred to each other. All those mixed flowers. When he did it, red to red, same. White to white, same. So he designed an experiment. When he hypothesized, postulated. His educational guess was somehow the genetic material is transferring from one flower to another flower. And later, after his experimentation, designed the experiment, got the results, and found out percentage-wise how many were mixed, how many were white, how many other. So at the end, he concluded that my hypothesis was right. There was transfer of genetic material. These are the steps of scientific method. And now you may be asking, what is engineering? Are you asking me? Engineering method starts with a problem. There, observation on both sides. One comes with question why it is happening like this, why apple is falling down. On the other hand, engineering method start with the problem, I cannot cross the river. I'm trying to explain you in the simplest way. Okay? Are you all teachers? Good. So, what we should do, brainstorm. A scientist, an engineer, brainstorm. In what language? Our own language. Okay? And say, what shall I do? How shall I cross the river? The river is so deep and it is flowing so hard, and I can't even walk through it because I will get drowned. So what comes to your mind? Tell me, what comes to your mind? How you are going to solve the problem? Here is solving the problem. Building a bridge. Any other way? Any carrier which can go into the river and cross the river? What else? If I say bridge, use a bridge, which is, we have seen so many bridges. Are there different types of bridges? Are there any different types of bridges? Civil engineer. This civil engineer. Yes. When you are building a bridge, just don't go and put some logs across. You can have a big log that big. So you have to pick what material you are going to use. The next, when you are designing the solution, you have to think about what kind of a structure that will be and what material we are going to use it. And this is once, first what you do, you make a model of it. Am I right? Because once we make a model and then we test the model. And this is called prototype. The type which is going to be finalized, and this one will be proto. Before that, nice. Are you understanding? I'm sorry. I know you don't understand Hindi. How many of you understand Hindi or Urdu? Quite a few. Good. That's why you are smiling. So prototype. Prototype could be anything, any new thing. And to build a prototype, you need a technology. See now, we have, in America, we have, this tell me when I have to start. 15 minutes? Okay, I don't need to start now. All right. So, what was I saying? Now, we want to cross the river. And there is a bridge and a container inside. And that container could be a small boat. Isn't it? Could be a boat. So, but you cannot put a small boat. The water current is so heavy and strong, it's blown away. And that's not working. So the engineer decides, hey, boat is okay. We can do it when there is not much flow in the river. When there is not a rain and water is gushing into the river, it's different. Well, he thinks that's bad thing. And now we have to find out what kind of material shall we use wood? Shall we use concrete? Shall we use iron? These things, when students participate in science and engineering fair, this type of thinking starts right from the 4th grade. Then we can have every year one such meetup. Abdul Kalam Azad, or not Abdul Kalam? Abdul Kalam, our missile man. He had a great love for science. I have not invented anything, but that doesn't mean that I do not have a desire to invent. Because when I was admitted to medical college here, I studied everything, I love science and did medicine. Not a single paper I wrote. Because that type of thinking Professor like that. I wish Amit sir, professor like him. Every teacher should be like him. Every lecturer should be like him. You know, so these students will brainstorm and say, oh, why can we put a column? But how many columns I have to put under the bridge to hold the road on top? Okay. Why can't we put only one column? Have to calculate. So when you do engineering, mathematics comes. When you do any kind of science, mathematics automatically comes. And these students write themselves, make notes. So that the writing ability also increases when doctors, after passing philosophy, they sit, they memorize thousands of questions and they get good score. And they apply for residency in America. You ask them any questions which needs creativity and critical thinking, zero. You ask them, go ahead, you do the research and write down and bring back the manuscript. They can't even write a single English sentence correct. English medium. I wish they studied in Tamil. Nowadays, AI can easily translate your Tamil into English. You don't need any English medium school staff. Stop them. Who is making money? The owner of the English medium schools. They are minting money. They are driving BMWs. You are putting petrol in their cars. I'm sorry if there are any, management of the school here. I'm not talking about colleges. I'm talking about the basic education. Right? So now, what you try, you estimate how many columns you need. Remember? Then what you do is, oh my God, this time river was so heavily flowing, it took away the columns. Now, another problem arises. What to do? Can anybody tell? I will give some money. Can anybody tell? Because what shall we do? What is that other alternate? Just give me some examples. Give me some examples. I can go on the whole day like this, and you will be here forever. Okay, we'll say we will replace cement, concrete blocks. Okay, yes. Then what you will do? Reinforced concrete, iron, and all that kind of stuff. Even that didn't work. What you will do next? Floating bridge is not called floating bridge. Floating bridge can break through because river stream. That's a good thought. And we do that. You know who does that very often? Our Navy. Military. They do it. But again, the river should be silent. Okay? What? Who said that? Amit sir said, Dr. Great scientist said that hanging bridge. Oh my God. Do you know any hanging bridges? Do you know any hanging bridges?
Babylonian hanging bridges.
Which one? Do we have hanging bridges? Chennai?
No,
China? No, China has it. Not in India. Oh. our engineers, what they are doing. Washington Bridge. Have you heard about Washington Bridge? It's on the Hudson River. And it is at 2 levels. The cars will be going and coming from one level. You can choose whichever level you want. It's hanging. There are no columns. So usually we see the ropes going like this. So today, that's your homework. Hanging bridge. Find out. Okay? Now, so similarly, I think this one example I give. So you made a prototype, and that prototype you start working on. You test it as a model. The prototype, you put so much weight on the bridge, and at one time it collapses. Then you try, instead of using wood, iron. So does it hold better? And what kind of, forces are acting on bridge and how it should transfer from one end to the other end? You have to calculate. After calculating, then you think that prototype will hold about 100 tons of metals going on that. If you try to load up that bridge with more than 100 tons, same thing happens in the elevators. Isn't it? They said no more than 200 pounds or kilogram. Something they write. Why? What happens? Then the road will break and the elevator will get collapsed. So everything, see, because there are people who cannot walk, they have arthritis. Now we have to revise. That's the problem. They cannot go on stage. I go every day and I climb 178 stairs. Okay? Why? I don't take elevators. That's why I'm here, still walking. We start walking, then at one time we will be better. So the problem here was the how to climb the stairs. I cannot climb. I have pain in my knees, arthritis, osteoarthritis. So the engineers think about how to, they came with. Same thing with escalators. You don't have like the steps going up. You go to airport. Same thing, same concept, but different methodology. And great. So when they were building sky high buildings, then we think, oh, that's the big beams. You can't go from inside. It's very different. So somebody thought maybe we should take something and put it on top of it. Why these simple thoughts are not coming to our engineering students? Because our product is like that. English medium is killing this country. They can't think. The only goal they have to speak. Oh, Dr. Azhar is speaking such a good English. I wish I could speak like that. But I'm not feeling the same way. Yes, I can speak. Why can't we speak Arabic like that? We make more money in India. We have more income from Middle East than United States. Why can't we start Arabic schools here? There will be chefs will be very happy and give you a lot of jobs. Oh, US is too far away. 3 hours, 4 hours. Very sorry. We don't care. From today onward, those teachers who put their kids in English medium, transfer them to Tamil medium. Will you do it? And go and pray 2 rakats. Sorry, Allah, I did a big mistake. Will you do it? At least tell others. If other teacher is putting, then I did a big mistake. Now he's in 8th grade. I cannot bring him back to the 1st grade. Tell them. And they will be great scientists, engineers who will be inventing. Because I'm an educationist as well as scientist, so I have to tell them. When you are thinking in your language. Am I right? You're not thinking foreign language. So, but anyhow, 15 minutes, Dr. Nazar. Shall I take 5 more minutes?
Yes, sir. Yes, sir.
And, okay. So what you did, you built a prototype, and the prototype is not working. You go back and modify that prototype, change the prototype, so that you can meet what is desired. Right? So when you were building the plane couldn't lift more than 50 feet. It flipped up. And what you have to do? More weight on the other side so that it can go up. So we started change our prototype. So and when you do this, you have to record that how many feet it went and at what point kind of it worked. So you take all the measurements and weights and draw a graph. Ultimately, when you succeeded in your prototype, then you will. Why bridges collapses? Because some engineer is not doing the right job. They are not calculating. Cement, iron is there, but is this the right quantity of cement and right quantity of iron? If the engineer kind of, how corrupt we are, have to make more money and reduce the concrete, reduce the iron bar, of course, it's going to collapse. Let down. So until at the end, you come up with conclusion. What? So there is a difference between scientific method and engineering method. Observation is there, but engineering method starts with good. That's how I asked you that. Why is the open? So, and okay, so if you come up with a problem, like, want to fly, like a bird, you make a prototype, a small airplane, and you try yourself. And in the beginning, people will try their wings, and they try to fly, and that's how that was the first prototype. And then they said, oh, I can make a parachute. But parachute is completely like a half balloon. You fly everywhere. You cannot come down. So you have to make a hole. See, how students love this. Kids will love it. Fantastic. But we don't teach them like that. Every engineering book should have engineering method as the first lesson. No, we don't have. So with this, I will, I'm sorry I get very emotional. Sometimes I become very emotional. And make you emotional too. So I'm not a motivational speaker, believe it or not. motivational speakers, you have to put a banner here. No motivational speakers allowed. You know why? They come, they say stories, they do this, go into the bathroom that this and that. Is it going to help you? What I taught you today definitely help. They don't come up with this because they don't have knowledge. You know how much we charge? Up to 1 lakh. 2 lakhs too. And I'm coming here free. How much money you will give? Oh my God. Thank you very much. I appreciate that. Made my day. Thanks a lot.
Thank you, sir, for your insightful address. With the successful completion of the first technical session and a wonderful start to our day, we will now be taking a short break. We request you all to kindly reassemble after 10 minutes as we will resume with the next technical session. I request all the staff members, how the Gen faculty will have a tea and outside the seminar hall, and lady faculty resume in the seminar hall. Tea will be provided inside the seminar hall. Thank you.
How do you design the experiment? How will you tabulate the data and collect the data? How will you analyze? That's all we ask for. That is called research protocol. Nearly 600 to 700 protocol we receive, but we select only which are up to the mark. Nearly 200, 250. They will be given the time to do the experiment. They will be submitting the synopsis. From that, only we select 100 or 100. See, over the years, what we have achieved. Out of 700, I filtered to 100. What we have achieved? What we have achieved is all the students follow the scientific methodology. They do the experiment. They do the work as a scientist. What is missing? That is the concern. What is missing is, see, we aim at it is national level. From this, they should go to the international level. For that, entry is Irish Science Fair, you know it. IRIS, Irish Science Fair. Okay, if the student gets selected in Irish Science Fair, Government of India is responsible to take them to participate in the International Science Fair at the Los Angeles schools. But get our student to entry. Why not it happen? That's what Irish to one also good or our students project coach ana select ஆகும். ஏன் சொல்லுங்க ஏன் ஒண்ணு இல்ல சிம்பிள். ஐரிஷ்ல என்ன பண்ணுவாங்க, உங்க டைட்டில கூகுள்ல டைப் பண்ணுவாங்க. உங்க டைட்டில அப்படியே கூகுள்ல டைப் பண்ணுவாங்க. It should not have been done earlier. It should be 100%. So what is lacking here is, if presently our student know to do research following the scientific method. They have developed the skill, but what is lacking? Originality. That is what the appeal from the moon here. You think originally, come out with the original project. Don't make the price come off his own. What you originally think and work, you may fail, but it's also a success. If you try again and come out with the original product, so that is the first step. Number two, see, one concern is at the college level, undergraduate students are not exposed to research. Some colleges, PG level, there is research. So we are extending to arts and science college this year. Okay, that is the one. Again, we expect the original product to come from the college. One more concern again. That is why we gave the topic engineering to Dr. Azhar. Main reason. That is mainly the engineering projects. Particularly in physical science, also working models. The student devices, solar cell, some other device they are coming up. It's turned to be an exhibit because they just make a model, make it work, measure and keep, but nothing innovation in it. So they should have an engineering work. They should have a, for the device, it should be the efficiency. In international science fair, one student developed a one pattern. Okay, simple pattern. He developed. His engineering goal was, its output should exceed the lithium ion battery we commonly use. So that is the goal. So he did one prototype. The output was, voltage was less. Then he varied the electrode combination. Second prototype, little bit the voltage increase. Again, he developed 13 prototype. 14th one gave the output on par with the lithium. So devising the cell is not new, but the combustion of nature of the electrode or composition of the electrode made the difference being cheaper in the market. So, second appeal is even in the physical science project and engineering science project, if you are coming with a working model, let it not be the only one prototype. If it is a one prototype, you try to do the variation, do the experiment, bring it, and don't bring it as a exhibit. Again, I am telling you, we are extending to college. You have particularly mentioned the robotics. In robotic and all, mostly it will be exhibit. They will be making something, it will have some task is already been done. Now it has gone to the very great extent. Doing a robotic may look great, but not innovative. So that is the main appeal to the all the participants. Now we listen to our great resource person, Mr. Samin Raja, Dr. Musai, Dr. Majid, and make note of the things. Inshallah, come out with the original project. Let us take our students to the ideas and then to the international. That is our objective. May Allah accept our efforts. May Allah give the maximum benefit to the productive result to the whatever the efforts we take with this effort.
Thank you, sir. Now I invite Mr. Samin Raja, Principal at Rahman International School, Melur, Madurai, to deliver a lecture on preparation of physical science projects.
Assalamualaikum. Happy morning to all the research guides who are sitting over there. Now I want to address you as research scholars because from the morning everybody is talking about the research, fact, projects, all these words are hearing often, right? So you are the ones who are going to guide our young scientists. So I want you to address us research scholars. With this, I will start the session. So before that, this is a platform. I think this will be the best platform for me to thank my teachers, Nazar sir and Baji sir, from whom I learned the scientific methodology. A few years back, I'm also like you. I sit there and I listen to Nazar sir lecture. I still remember those days. I had taken every notes. That's the first time I hear the word scientific methodology. I didn't learn this from my school days. I learned from him and I aroused the interest and I started to implement some steps and from him I learned. Thank you sir for the learning I had made from you. So நான் ஒரு விஷயத்தை உங்களுக்கு ஃபர்ஸ்ட் இன்ஸ்பயரா சொல்லணும்னு நினைக்கிறேன். ஏன் இந்த சயின்ஸ் ஃபேர்? Because I know that I'm also working as a teacher as well. Along with the principal role, I'm taking some classes as well. So I know the burden of the teachers, practical difficulties. Even among those practical difficulty, நம்ம ஏன் இந்த சயின்ஸ் ஃபேர் நம்ம எடுக்கணும்? Fazil, please show that ஒரு picture அனுப்பிச்சாங்க. Just play that. I want to share my student participation in China Science Fair, and he won the second prize. So morning, Hamid sir, I think Majid sir, morning tasting medical. Most of the students they are not showing interest in doing research because they are spending much time in their studies and practice, right? Currently he is doing in Hawaii University. He is currently doing medicine. First, when he studied 4th standard, he participated in Homeopathic Science Fair and he didn't get the prize. He literally cried. நான் இங்க சென்னையில இருந்து till I take him Madurai. He is the student who used to put lot of effort. He did the project on his own. But sometimes because நிறைய projects இருக்கேனா success இருக்கும், sometimes loss இருக்கும். He cried. Again, when he came 7th standard, again he did one project and that project he owed the prize. In the experience, now he is currently doing second year in medicine and So maternal mortality rate, China and Indonesia women every he did a survey and he along with his friend they participated in the science fair and he is the one who defined the whole project in the scientific methodology and he won the prize. And this credit goes to OMIAT too. So I use this platform to thank Nalda sir and sir and the entire team for giving this wonderful opportunity to us. The boy who is standing as the first, he is Abdul Rahman. And with his friends, he did this fair.
Is it very campus project?
Maternal mortality rate. It is purely related to medicine. But he applied the scientific methodology, what he learned from our school. And this is the board he created and presented. Okay. Okay, so we'll go to the presentation. No, they voluntarily participated in a science fair and they owe the prize. It's a group project they did. Yeah, okay, sir. You can go for the presentation. So they have given a list to complete the scientific methodology within the allotted time. So as we said, நம்ம தலையில இப்போ ஆப்பிள் வந்தது ஆப்பிளா பத்தி திங்க் பண்ணாம சாப்பிட்டுருந்தாங்க அப்படின்னா என்ன ஆயிருக்கும்? You never have discovered the gravitational force, right? We usually tell the science teachers to take your science class always by giving answers. Let the students come up with questions. Let them come up with some research question and you try to guide them, you try to facilitate them how to find out the answer to those questions. So எப்பவுமே நம்ம யூசுவலா ஸ்கூல்ல என்ன பண்ணுவோம்னா தியரி எல்லாமே சொல்லி கொடுத்து முடிச்சிருவோம் and after that we used to take the student to the practical lab, right? But this should happen in reverse. So by doing the practical classes we should teach them the science concepts. Yeah. Nasa sir, he said, right, the difference between the science expo and science fair. Usually in the science exhibition, what we usually do now, we usually watch the YouTube videos and we prepare huge models. We spend much time and energy and much money to purchase those materials and we fix. We are just imitating whatever the YouTube person is doing, right? There is no innovation, there is no space for individual thinking when we participate in the science expo. But science fair is totally different from the science exhibition. In science fair, we should let the student to think, to research, to find out solution for a problem. He need to think on his own. He need to apply whatever the science knowledge he learned through his studies. So we should prepare science fair in such a way the student should be given opportunity for his critical and creativity thinking. So this is the scientific method. So scientific method starts with observation. Usually what we used to observe, we used to observe those things, right? If you are traveling in a bus from your home to school, if we observe any building, different colors, colors, the different structures are constructed. We used to observe through our eye. That we will remember that. நம்ம வீட்ல இருந்து ஹவுஸ் ஒர்க் ஸ்கூல் வரைக்கும் வர எல்லாத்தையுமே நம்ம ஞாபகம் வச்சுக்க மாட்டோம். எதுக்கு நம்ம நிறைய அப்சர்வ் பண்ணி மைண்ட்ல ஃபிக்ஸ் பண்ணிருக்கோமோ அதெல்லாம் we tends to remember. So the science fair first starts with the observation. Students used to observe whatever they are interested. So next observation kaduthu enna irukum? If we observe, what comes to your mind? we will ponder, we will question, right? Why it happened? What if it happened different? We used to question, right? So the second point comes the question. So this is the second step in the scientific method. First, we used to observe. Observation mostly we used to observe through our five senses as well as through some apparatus. So some instrumentation will help us to make some observation, right? And then those observation leads to some research question. That research question further needs some investigation to find out what, how, and why. Okay. So the third thing, so for framing the question, this is a sample template. You should. It is not that you can exactly use this format. These are some templates. Here and there, I have given few templates. Even for activity, I planned one template. Since we don't have time, maybe each school can get that activity template, and you can have this activity with your science teachers at school. So, effect question. So, what is the effect of sunlight on the growth of plants? What is the effect of eye color on the pupil relation? So, you can frame this effect type of question. So, you can frame some effect type of question. So, how does the color of the light affects the growth of the plants? How does the color affects the absorption rate of the different materials? You can frame this type of question, and as well as which type of question also you can frame. But this question must trigger the investigation. And then we need to do some background research. Yeah, we are not we don't have a bunch of knowledge in all the areas, right? Since teachers, we are majoring one subject areas, but here we are encouraging the students to do research from the primary level. So if a primary level student asks different question in different stream which we are not master, we should let the students to do the background research along with the students. We can also do, or we can also make contact with the experts in that particular subject area. Nothing wrong in it. So please don't restrict the student to select the project or the thing within your known stream. So we can talk with some experts as well. So background knowledge, it is not necessary for us to collect the background knowledge only from the web pages. We can encourage the students to read the science journals. Science magazines are there. We can ask them to get to have an interview with some subject experts. So we can make them even to observe some interviews of a great scientist in that particular field where the student has selected the question. Right, so we must encourage the students to do the deep background research. Most important thing here is whenever we are encouraging the students to do these type of background research, encourage them to note down all those things, whatever they learn from whatever the sources they have visited. That is much more important, okay? Because usually we have seen many students have the habit of they will complete everything, and even they get the link from the Google. Give the link for the title, like that they used to browse and copy those things. Don't encourage the students to do that. Give that. Don't and allow the students whatever design please don't allow. Ask them to write the link exactly whatever they learn. Background research and then hypothesis. Okay, they had a question. They did some background research based on the question, right? So they had some knowledge about that particular thing, right? Now it is the time for them to frame a prediction. This is time for them to have an educated. This is a logical representation. This is like the logical answer to the question. What is the probable answer for that? Okay. This is much important, and till the end of the experiment, till the end of the fair, the student should not change the hypothesis, because throughout the project they are going to design the experiment to test whether their hypothesis is right or wrong. Simple tips to frame the hypothesis is hypothesis must be in a simple sentence and it must be in a present tense. Okay, so don't let them, even the hypothesis is not proven, the method will again, we can repeat the again method. It is not necessary always the hypothesis should be true. So then we have to design the experiment. So to design the experiment, variable selection is much more important because this is the major building blocks of the experiment. There are three types of variables. One is the independent variable, and then the second one is the dependent variable, and third is the controlled variable. These three variables is much important for the scientific method. So independent variable is the one which we intentionally change. That must be one variable. Okay, if you want to, for example, if you want to test the temperature, the rate at which maybe I can tell if you want to measure change the temperature and check at which temperature the efficiency is high. Means here you want to change the temperature level. The temperature is the independent variable which you intentionally change. And based on the temperature, you are going to measure the efficiency of something, right? So efficiency here is the dependent variable. Okay, dependent variable is the one which you are going to measure. And the control variables are, control variable you should have many control variables. Control variable from the beginning till the end, these variables must be maintained same. For example, the same beaker size, same type of liquid material, same temperature, room ambient temperature. So the control variables, so these three variables are much more important while designing the experiment. Even in the hypothesis statement, you should include the variables part as well. Maybe if we go after this, actually I planned an activity where by seeing the hypothesis statement, you should extract these three types of variables from the hypothesis. So you must ask yourself, what are the factors am I trying to test? That is the independent variable. And what are the factors what I used to measure at the part of this fact, that is the dependent variable. And what are the factors that I need to keep constant throughout the experiment, that is the control variable. I had add examples, shall I explain or example? Okay, fine. For example, here we need to investigate how the weight affects the length of the string. Can any of you tell? I had given the statement. We need to investigate how the weight affects the length of the string. In this case, what might be the independent variable? Anyone? Weight? Independent variable, right? Everybody is agree? Okay, and dependent variable? Length, because we are intentionally changing the weights. We are adding weights and we are reducing the weights. According to the weights, the length of the string is changing. So that is the dependent variable. What might be the control variable here? Material of the string. Very good. Length of the string. Yeah. So we have to use the same string, same length. And then any other thing? We should not add any more external, we should not give any more external force to, right? Check. So we must have the same elastic band all the time and same scale. Okay. Let's take the next few examples. So, for any science fair, both the control group and experimental group is much important because we used to compare the experimental group with the control group. For fertilizer, test fertilizer I use panni, and the fertilizer effectiveness நம்ம பார்க்க போறோம் அப்படினா fertilizer போடாம இருக்கிற என்ன மாதிரி growth இருக்குன்றது தான் நம்மளுக்கு கண்ட்ரோல். சோ அந்த கண்ட்ரோலை வச்சு தான் fertilizer ரேட் நம்ம இன்கிரீஸ் பண்ணி அந்த fertilizer எந்த அளவுக்கு growth கொடுத்திருக்கு அப்படின்றத நம்ம மெஷர் பண்ணோம். So this control group must be there along with the experimental group. Without the control group, you can't prove your hypothesis are right or wrong. Because that must, இப்போ ஃபார் எக்ஸாம்பிள் ரொம்ப சிம்பிளா நான் சொல்லணும் அப்படின்னா ஒரு இது ஹைட்டா ஷார்ட் ஹைட் கம்மியாங்கிறத நம்ம எப்படி சொல்லுவோம்? யூஸ் டு கம்பேர் திஸ் வித் ஒன் மோர் திங். ஸோ இந்த ஹைட்டுக்கும் இது கூட இருக்கா கம்மியா இருக்கா அப்படிதான் நம்ம பார்ப்போம். ஸோ கண்ட்ரோல் குரூப் மஸ்ட் பி தேர். This again is the activity I prefer. Okay. As well as our experiment must be fair. What does it mean? What makes our science fair as a fair test? So first one is that you should keep one thing. You should change only one thing at a time. If you want to change the temperature now, at the first time you should change the temperature alone. Ohm's law vachina so the voltage ayum maati current ayum maatadala. So we have to change only the voltage alone at the first. So at the first time we should change only one. And then the second thing, you have to do multiple trials. So in the multiple trials, we can get more accurate answers. So now whatever test the test produce it won't be a fair science project. So we should make our science fair as fair by giving multiple trials, and we should take the average and sampling. If you are planning to do some projects, survey project, the sample must be high. You should not go with the 2 or 3 samples. Samples size also must be high. For example, if you are going to test juice, or you are going to check the concentration of the juice. To get the juice, you should not collect one tomato from one shop. No, you should pick more samples. You should get more samples and you do the same experiment with more samples. And the more samples that you have to test at the same time. Okay, physics lab, you can easily do more trials. So the current voltage increase panni, the apparatus will be there and we will do. For biology, for botany, because we need to measure the height of the plant and what you have to do. You should go for much sampling. Okay, before fertilizer, again the same project I am taking. If you want to check here effectiveness of a fertilizer, how many sampling you can prefer? Any guess? எவ்வளவு samples வச்சு டெஸ்ட் பண்ணி பார்க்கலாம்? ஒரு பாட்ல ஒரு கொஞ்சம் ஃபெர்டிலைசர் போட்டு டெஸ்ட் பண்ணி பார்த்தா இட்ஸ் ஓகேவா? Yeah, very good. So if first 5 gram la 5 parts, 10 gram la 5 parts, 15 gram la 5 parts, without anything or 5 parts. So you should increase the number of parts because ஒரே part la நம்ம ஒரே மாதிரி soil use பண்ணனும், ஒரே seed use பண்ணனும். These are the control variables here, right? So ஒரே part grow ஆகி வர வரைக்கும் we can't wait. So you should increase the number of parts. So sampling we have to be very conscious. So always do remember you should change only one variable at a time, and we have to increase the sample size and we have to do multiple trials. You should not submit only one set of data. Multiple data must be collected. But those data must be collected at the same time. For example, you are testing the wings, different shape of the wings soda. நீங்க flow rate நீங்க calculate பண்ணனும் அப்படி நீங்க plan பண்ணீங்க அப்படினா you should do that at the same trial at the same time. So cloudy days, because the temperature should be constant. Weather வந்து இன்னைக்கு cloudy ஆ இருக்கு, so இன்னைக்கு ஒரு report கிடைக்கும். நாளைக்கு weather வந்து change ஆச்சுனா according to the weather the change will be different. So those trials must be done at the same time. And then you should you collected the data, right? For collecting the data in your plan, you should go with a proper data table. To make a data table, there are certain rules you have to follow. You should give a proper heading and you should start with the independent variable first, because according to the independent variable, we are going to measure the dependent variable and we have to go with the dependent variable entry. And for the multiple trials, you have to give trial 1, trial 2, trial 3 space for those things and average column 1 as well. So data table must be planned properly and unit is very much important. What measurement you are taking, you have taken. That also must be noted in the data table as well. And for data collection, as I said, accuracy is much more important, and consistency and repetition. These three factors you must be very clear while collecting the data. Okay. The sample logbooks, I said right during the background research, what are the students, see, while you are taking your students to the science fair, ask them to bring the science logbook. Because those logbook is a proof that this is originally done by the student. From the first day till the end, what are the measurements the student had taken, what are the things, even they had taken any wrong measurement, even they had they redo the project, don't worry about it. Let them have the complete entry in their science logbook. And we need to present the data visually. That makes us to analyze the data in most clear way, right? You can use bar graph, line graph. Okay. Again, for making the data graph, we have certain rules. Independent variable must be in the x-axis, and the dependent variable must be in the y-axis. So this is the data. I had given few checklists for you to ensure whether you had created a good data table and data graph. So first thing, you may ask yourself, is there sufficient data to know whether the hypothesis is correct, yes or no? If you give yes to all these questions, then obviously your data table and graph are good one. So has the data been summarized with an average, if appropriate? Yes. Does the chart specify the units of measurement for all the data you had collected? Yes, and all the calculations are made correct. Okay, for the data graph, is it appropriate graph type? For example, according to the data you collected, whether you had selected the appropriate graph, whether a bar graph or a line graph or a pie chart, everything. Okay, is it appropriate? Is the dependent variable on the x-axis, sorry, independent variable on the x-axis and dependent variable on the y-axis. Next slide. So all the axes are labeled correctly with the specified units of measurement. That is also important. This is much more important. Does the graph have the proper scale, appropriate high and low values on the axis? Is the data plotted correctly and clearly? Next. So we came to the last part. That is the conclusion. So you collected the data. You represent the data visually. You have to analyze the data, right? Through analyzing the data, you should come to a conclusion whether your hypothesis is right or wrong, is proven or not proven. So you have to thoroughly analyze that. If your hypothesis is not proven, you can state that it is not proven and you can submit the reason as well. If there is any mistake in the project you had done, you can simply relook everything and we can start the process once again with the trials as well. So to communicate, we need to prepare the board. We need to submit a research paper. Along with that, you need to submit your logbook as well as you should come with your display board. Next, given the sample of the display board. Next. So this is the research report format. So the first one is the title page, and you have to give a small abstract what you have done in the project and introduction, hypothesis, the design of study, and data collection and research, discussion, conclusion, and bibliography. This is the order you have to arrange your research paper. And you have to make a clear display board in the middle of the, it is a 3-panel board. In the middle of the board, you have to present the results as well as the data that you have been collected. And in the left and right, you can give the hypothesis and your procedure, everything you can give. And regarding physical science, we have many areas, right? You can select projects from nucleophysics, astrophysics. You can select from mechanics. So many to select from physics. When it comes to chemistry, you can select projects of recording particles. Now you can use the nanotechnology, material science. So you can go the different type of branches. You should not. It is not necessary for us to stick always with measuring the height of plant, everything. We can go for some more effective subjects. As others are highlighted, the originality is much more important. For that, here I had taken an example from the ISF Science Fair, 2 examples. I don't know whether I have time to explain those projects. Rashid, did you get the scientific methodology flow? Can anyone of you tell me this is the flow so that I will get satisfied at least? Anyone? What is the flow to do a science fair using the scientific methodology? Now, first step is the observation. Sorry? Questioning. Background research. Hypothesis time to. So you have to design the experiment. Under designing experiment, you have to identify the variables, design the procedure, everything, and then collect data. During while planning for the experiment, we have to design the data table. How we are going to collect the data and what are the instruments we are going to use to measure and collect the data. Okay, and science logbook from the beginning we have to maintain. Okay, that should not come as a separate step. From the beginning we have to use, and then at last you have to prepare, analyze the result and submit the conclusion along with your research paper. So at least we right. Okay, so this is from ISOFAIR. So this is one of the project. So harvesting energy from the foodstuffs. It looks interesting, right? So I take on this project. So we know about the piezoelectricity, right? It is a type of electric charges which get accumulated in the material. So because of giving some mechanical stress, right? So using this concept, the student try to investigate, can piezoelectric materials generate sufficient energy from the foodstuff to power small electronic devices? This is the question aroused for that particular student. And for that research question, the hypothesis framed by that student was piezoelectric diodes using lead zirconate titanate will generate at least 5 volts per step, sufficient to charge a small battery for low power devices. Can only one please stand and tell? Don't tell the chorus answers. Anyone stand and tell what must be the dependent, what must be independent variable first? This one. They are responding. Somewhat here they are telling. But due to low frequency, there usually female have more frequency than gentlemen, right? Okay, anybody? Sir, first step is the independent variable, right? Any other? Material used. What is the material they plan to use? Piezoelectric. So P, the materials are the independent variable here. They plan to intentionally change the material. What might be the dependent variable here? Voltage, very good. What must be the control variable? Steps, very good. The force we are applying through the step, because here the mechanical energy is being converted into the electrical energy. So we should give the same amount of mechanical energy. Very good. And then the size of the tiles, right? The tiles materials may be different, but the size of the tiles must be same. And then any others? What about the devices? We used to measure the voltage, right? Yeah, that is a dependent way. We are going to measure the voltage. For measuring the voltage, we should have some experimental setup, right? That experimental setup must be constant. So the independent variable the student used was piezoelectric metal type, the lead, zirconate, and titanate, and PVDF. That is a type of one type of polymer, and then a control. And the dependent variable is the voltage, and the control variable is the step force, circuit design, and the measuring device and the type size. Yes, through this experiment, he found his hypothesis has been proven. So this project, this is the data representation by that particular student. She compared the voltage output by using the different materials. And one more project is there, later we have. So this is again one more interesting project that we're using the solar panel by giving anti-dust and anti-reflection coating. So you can refer few more web pages. See, as from the beginning, the originality, right? You can refer even ISF web pages to get more innovative projects, and you can try to do much more variation from that project as well. So next, I can add many examples for such projects as well. Thank you for the wonderful time you had given. Those who need the template, one teacher from one school can get the template. Using this template, you can see for the students, since we are adult, within 1 hour, you can learn the entire thing. But student must get practice. I have only 10. Yeah. One teacher per school you can get, later you can relax. And so please give practice to the students how to frame the hypothesis. Take very simple example. Because Sas said right, he got opportunity to research when he entered PG. What would have happened if he got the opportunity during the school days? Like the student that I showed, right? Because Omiyat had given the opportunity to the schools. So that boy, he felt very easy to apply that because he used to do the scientific methodology. So that's how we need to give the practice to the student. Even you can take small example and then give them the practice how to frame the hypothesis, variables, how to design everything, and then gradually you make him to switch on to the real original project. It will be easy for the primary and middle school children. For the college students, you can go in, but for the school students, you can gradually practice the methods. Thank you. I hope you had learned the scientific methodology. Thank you for the opportunity you had given. Thank you, sir. Thank you, sir. Thank you.
Thank you, ma'am. Now I invite Dr. S.G. Mohammed Hussain, Assistant Professor of Physics, the New College, Chennai, to deliver a lecture on preparation of physical science and engineering products.
Assalamu alaikum. I welcome you all to this workshop. And first of all, I would like to thank you all because it's very hard to take time during the weekends. And alhamdulillah, the hall is full. And it's already time for lunch, and we are two more speakers here. So kindly bear with us. And from the morning, we have been listening to research, and what is research? It's nothing but research. We have to search again, and inshallah, I will start with some examples. A lot of great clips from how the students are receiving the prize, so that will be motivation for us. But unfortunately, it's not working. So, what's the goal of NSF? So, we are attending this workshop for so many years, and actually, what's the goal? Next.
I think.
What we need. So it's nothing but to apply the scientific knowledge, like conducting research-based projects, promoting creativity, critical thinking, and the main thing is problem solving to address the real world challenges. So we have to think about what are the real world challenges, okay? And so before actually I'll start with few examples, some award-winning projects. So what we have to do, what really inspired the student in these projects, and how did they identify the research question? That we go through few projects that won the prize, and then we will discuss. Next. So a 12-year-old means what will the grade? 7 or 8, 6 or 7, right? So she won $25,000 in JIC. So actually, it's a fire detection system. How she got the idea? There was a restaurant that got fired. From that, she got the idea to develop a fire detection system. So how? Actually, she trained the system the way that it differentiates between the warm bodies, because it's a cold state. Human being will also have the temperature, warm, right? Warm body, and she differentiates between the stationary warm objects and the moving warm objects. In that way, she developed the innovative fire detection system. Next, since we have a lot of time, I'll make it fast. This is best natural fabric for reusable menstrual pad. How she got the idea? We saw a documentary film called Period End of Sentence. From that, she got the idea, because we live in a state where we are very much advanced. Even in India, even to this day, we have villages where there is no electricity. So she got the idea of developing a reusable, at the same time hygienic menstrual pad. This is the motivation. Right. Next. And a 14-year Samvik, he was affected by allergy. Whatever food he used to take, he used to get allergy. So for that, he developed a system where it will say, if you take this, you will get allergy. You will get allergy. So not only for himself, for others also. Right. Next. And this is so today we know whatever we eat, for sure there will be some sort of plastic. Even if when we Google, we can observe that our body will contain some sort of microplastic. That whatever, even if we eat seafood, it will have some sort of microplastic. So it's a problem, right? So she created a system which will detect the microplastic. So these are some of the examples. Next. So how to guide the students to find really research questioning? In these four problems, what we saw. So, Sister previously said that we need to observe, right? What they observe, they didn't go too far to observe things, right? This is what we want, but they found the solution for real world challenges. So we have to see around us, and easily we can find the problem, and we have to systematically find a solution to the problem. That's what we need. Okay. The first thing, what problem we personally face every day? Every day we are going out, right? We see the world around us. So what's the problem we are facing every day? And then we have to observe surroundings and see. The example I'm giving, right? What do you see every morning on your way to school or college or office, whatever it is? What do you say? So every day we see some problem. So how to find solution? And it will be of benefit to the society also. Next. So first thing, so reframe the observation, why and how. See, generic thought, plants grow slower in winter. This is generic, right? So how to convert that into a research question? How does the wavelength composition of winter sunlight affect the chlorophyll synthesis rate in plants? So this is how we have to modify a general question into a research question. So mild fan, so this normally we have, right? Makes noise at high speed. So how to reduce it? So when the fan rotates, what happens? Is the speed obviously we get noise, right? So how to reduce it? So we have to have some sort of aerodynamics mechanics in order to reduce the noise. Next. So it has to be specific, measurable, and comparative. So, example, how can we improve solar panel efficiency? This is general. So, how to make it more specific? That's adding any coating, any sort of coating, nano coating, any coating will improve the UV observation and increase the. So, what we want from solar panel? We want maximum output, right? So, what we have to do for that? So, this is how we have to frame the research question. Next. And then, as we said, as Narcissus said, you have to see for in the Google whether it is present or not. So search the exact question. If it is there, so we have to go for interdisciplinary or multidisciplinary. Add something to that so that it becomes novel. So if the result exists, has a new variable in a new angle. I'll give some examples for that, inshallah. Next. So check the scientific literature, not just Google. Not just Google, you have to go for Google Scholar, Semantic Scholar, like that. You have to see to get new ideas. To go for Google, it will be like general. Next. So you have to cross domain combination, originality. See here, sound. So I said, right, it has to be like multidisciplinary. Sound, solar energy. Can specific sound frequencies improve the photocurrent output of solar panels via photoacoustic vibration? So like that, you have to combine two fields in order to make it a novel idea. If it is single field, it may be available already. If it is two, you have to add the third domain. So like that, if you add 2 or 3 domains, you'll get a novel and interesting research question. Next. So document the process. All the process you need to document from the beginning, as mentioned by the sister, right? So you have to have a logbook. It need not be clean and like a record note. You have to scribble everything. Whatever you're doing, you have to record it. Whether it is correct or not, you have to record. Then, so these are some of the examples I will give for you, so that you can frame the questions, right? The first thing, renewable energy innovations. Question number 1. That's addition of any nanoparticles to water improve the cooling efficiency of solar panels compared to plain water cooling. Why so original? Because it combines nanometer science with practical solar panel cooling. So this is how we have to combine the two domain to get a new research question. Next, how does the changing the twist angle of the blades affect ability to vertical wind turbine to start? So again, like this, you have to combine. I'll go to the next question, right? Can recycled PET bottles filled with water be used as effective thermal mass to reduce indoor temperature fluctuation in low costing house? So how to reduce the temperature using these things? Again, why this original? This alternative thermal mass material combining with environmental energy engineering. So that's why it is a novel and it's a new question. Next, just you can take a clip of this so that you can frame new questions. Okay. Now, that's just now we have been listening to piezoelectric energy, right? So you have to combine that with triboelectric energy. What is the triboelectric? Nothing but so piezoelectric is because of mechanical stress, right? So triboelectric, when two metals come in contact with each other, it transfers electrons because of the charges created, right? So like that, we have combined the two domains. So how does again the placement of magnets by changing the proximity of the magnets? How does the output increases? Next. So now mechanics and materials. Again, everything is based on physics and energy. All these questions are based on physics and energy. New ideas. Okay. So does coating bicycles with hydrophobic space. Hydrophobic phase placements which not affect the water, right? So it will increase the speed when you go in for cycling and all, right? So like that you have to think. Next, then previous one. How does the roughness gradient on inclined planes affect the rolling friction and acceleration of cylinder objects? So what do you understand on this question? What does it mean by roughness gradient? So in this project we'll be discussing about robotics also, right? So about mechanics. Roughness gradient in the sense you see when a ball is rolling down inclined plane. So in the beginning it will be of low speed and as comes down, the speed will increase. So by varying the roughness, it will come at same speed. So in the beginning it may be smooth, as it comes down, the roughness will increase. So that it can have the same speed. So like that you have to think. Next. So this is environmental physics and local solutions. So all these things next. Next, we will see some examples. So research, how to do a research. Now, this is an example. The coating the underside of, see, we have been seeing about the solar panel, right? The solar panel, the sunlight will fall on the panel, right? So, how to increase the efficiency by getting the light from the beneath of the panel? From, see, it will be like normal ground, right? By varying the ground, making it the aluminum foil or glass with a black cloth. So like that, by varying the beneath the solar panel, how to increase the efficiency? So why this is simple? Because use base materials like aluminum foil and solar panel multimeter. Why it is novel? Because most existing studies focus on front surface. All the studies focus on front surface, not on the rear side, right? And unlike physics, it's reflection and photon capture, and all these things are there. Next, fine, full experimental plan. So, what is the objective? So far we have seen how to observe, how to frame a question, all these things, right? We'll do a real project, real-time project. Right? First thing, what is the objective? To determine whether placing a reflective aluminum foil under the solar panel increases its power output by redirecting scattered light onto the active surface. So capturing the light on the panel and also beneath the surface, from that it will reflect so that the efficiency may increase or not. This is what we are going to check. So hypothesis. First thing, when we frame a question, we need to frame the hypothesis. It doesn't mean that we have to get the same answer. The hypothesis and result may contradict, no problem. So if the reflective surface is placed below the solar panel, then the voltage and output power may increase. This is what we are. This is the hypothesis. Next. What are the materials required? So we have to, when we are designing a project, we have to do this. What are the materials required to do the project? Solar panel, multimeter, aluminum foil, and non-reflective surface, lampstand. So all these things are required. Next, the experimental setup. First thing, you have to connect the, so all the things we know. We have to connect the solar panel, the multimeter, the open circuit, and closed circuit, and select an outdoor location. So it has to be in an outdoor location, right? So where we receive maximum light. So all these things we have to design, and also it can be a variable. We have so many controls, right? So it can be variable, like we are performing the experiment inside the room, in a park, in a desert, or in a beach site. So we can do all these things. So what is the baseline? So place a black cloth or cardboard under the solar panel as a non-reflective surface. First thing you are doing with a non-reflective surface. Then you are making it as a reflective surface. So what is the difference between these two? Next. So this measurement with reflective surface and this measurement with non-reflective surface. Both you have to do. Then you have to compare the measurements with white painted board, mirror sheet, bare soil, sand, grass, whatever thing we have tested all these things. Next. So recording table. So these are the things we have to record. So I give just two things. For every 5 minutes or every 1 minute, we have to make the recordings. Not only for 1 day, that repeat this for so many days. And how it changes, we have to note it down. Next. Then data analysis. This is one of the important things. This will give the result. When you analyze the data, in order to get the result, we have to analyze the data. So you have to check all these things. Next. Precautions. So while doing any experiment, precautions is very important. Always we have to be careful. It should not affect us. Because some experiments may be dangerous, so you have to be precautionary. Okay. So conclusion: the experiment showed that placing a reflective aluminum foil under the solar panel increased the voltage from dash to dash. Because first thing we have tested the output without the reflecting panel, without the reflecting surface. Then we are again doing the same thing with the reflecting surface, and we are changing the reflecting surface like aluminum foil or it can be a glass, anything. So like that, we are changing the reflecting surface, and we are saying that the voltage has changed from this to this, and the current has changed from this to this, or the output power overall, because P is equal to VI. So how the power changed from one point to another point. This is what the conclusion plan. Next. The extension ideas. Test with different diameters and different reflective surface, so you'll be getting so many results. So real world applications. So low cost efficiency enhancement for rooftop solar installation and design modifications mounting structures with integrated reflectors for improved energy. That is what we need. We want to have maximum output with minimum changes. Right. Next. How it is benefit to society? Enhancing energy planning and management and educating raising awareness. So these are the benefit to society. Or actually, we have to observe around us, and we have to get a question, and we have to find the answer for the real time challenges. Next. So this is what NSF aims for. How your project has to be presented for the National Science Fair. So these are the things we need to have in the template, right? First thing, you can see all these things, right? So after all the personal introduction, we have introduction for the problem. What is the engineering problem and goal? This is for engineering side. Second thing, so you have to include all these things. What problem are you trying to solve? So as I said, first thing, you have to observe and you have to get a problem. what is the problem you have to mention. And also, you have to give the story, how you got the problem. So in the 4 examples, what we saw, they got the problem from their own story, right? So you have to define the story, which will add the present introduction to the problem. Then explain what is known or already done to solve the problem. As I said at the beginning, the research is nothing but research. You are searching again. So you have to mention what is already present and what I am going to do in this to find the solution to the problem. Next. First thing, you have to have the introduction. Next. Method. What method you are following and what do you plan to do and what is your plan of procedures to test the prototype. So prototype already mentioned, right? So it's not be one, it should be repeated. And then you need to give the results and conclusion at this stage, the research plan. Or you have to give the hypothesis, right? Next, you have to give the beginning, so you have to give the hypothesis, and the end, you have to give the results. Whether it matches to the hypothesis or it contradicts. Then you have to give the references. Next. So these are the things. So I made it very short, right? Because I want to be very quick because we have another speaker here. So any doubt in this presentation? You have doubt? Let's solve it yourself. Because we extend the time. Because already it's like 1:25. We have reserved for next talk. I hope my speech is clear. If it is not, please give the feedback to the team so that I correct for the next time. Sure. Like I highlighted, just a small video for refreshing. But for next talk.
Thank you, sir. Thank you, sir. Next, I invite Dr. S. Abdul Majid, Assistant Professor of Zoology, C. Abdul Hakim College, to deliver a lecture on preparation of biological and environmental projects.
Assalamualaikum and good afternoon, one and all present here. First, I would like to thank Mr. Sir for giving this opportunity for me. Usually, Nasser sir used to give the presentation about their biology and chemistry, but this time he is given the offer for me. I think this is the first time Nasser sir's presentation is not there in this program. May I correct, sir? And here, what we want to discuss about how the project we want to design in biological field or environmental field. Based on this, next 30 minutes we are going to discuss here. If you have any queries, you can ask us. First, what is research? Here what we have given the detailed study, especially in order to discover new understanding or new information. This is the research. When you want to design a research, before that you have to go for literature review. When your student bringing some project that, Madam, sir, I have designed this project. Before going to the project, first you have to collect the literature. Based upon the literature collection, you can design your project. Here what we have given subject especially in order to discover new information or new understanding. Already many research is there. Based on that research, you are going to design your research. But that research should have some innovation. For example, someone has said that based on this parameters, fish will grow in this weight in this much day. You are working on the same fish, but you are changing the environment. In how the growth was there in that environment, you want to record, but some novelty should be there. While reviewing this project, what we will be for the reviewer in this project reviewing, while that time what they have given instruction for us, novelty should be there. Based on that, we select those projects for snapshot submission, then for final submission. Here what we are telling, new discoveries, new information, new understanding should be there, and then what explain. Here what good research design should be like this, empirical, based on the experimental result, we have to present our research, our project. Example, you are doing some preliminary experiment. Based on that experiment, you have to design your work. That is called empirical. Based on the observation and experimentation, you have to design your work. Next, systemic. You have to follow the sequential procedure. You cannot tell anything, something new in the materials method. There is some sequence is there. You have to follow that sequence. Your experiment should be in this sequential manner. Next, control. I think already both the speakers they speak both about the variables. Here, what control? All the variables except one. Everything should be keep as constant. The control. Example, you work on some fish with some toxicant. You are giving only the toxicant is variable. Other things temperature, water parameter, everything should remain constant. There is no control. Next, hypothesis. Before starting the experiment, you have to design one hypothesis. Hypothesis you should not change based on your result. You have next to one hypothesis, whether it is accepting your hypothesis or rejecting your hypothesis, you have to accept. Before starting your work, you have to fix the hypothesis. Next, analytical method. There is theoretical analysis for data analysis. Then objective should be clear and your result should be unbiased. If you are doing some research, you won't get result. You should not manipulate. There should be no bias. Your result should be unbiased. Then logical. Then the employees quantification and statistical method have to follow. While designing your work, you have to follow the statistical method. Next slide. And for biology, different fields are there. If you take biology, applied biology is there, basic biology is there. It is not necessary that we have to spend much money on research. If you are going for basic biology, nothing you will spend more than 500. If you are going for applied biology, there you have to spend some money. There, if you see different fields that in basic biology, you are working with some morphology, many insects there. Still, it is undiscovered. If you see the local around 10-kilometer radius, many insect, aquatic insect, it is not yet discovered. If you want to work on that, you can bring some insect, kill it with formalin, observe under microscope, you can discover some new insect. You can report the first report in the world or first report in the India like that. You can there just you need one microscope. If microscope is there, with that you can do your research. And morphology, physiology, embryology. If you go for embryology, for school students it is difficult to work with embryology. If they want to work with embryology, with fish embryo they can work. Zebrafish. Zebrafish embryo is there. That the zebrafish embryo they can use with some small dissection microscope. That microscope alone costs around 800. With that one single microscope, they can take the photograph with the mobile camera. That's what they can work with the embryology in zebrafish. And other fields is taxonomy, ecology, genetic evolution, paleontology. Paleontology you won't applicable for the school student or college student. But other fields are advanced research like molecular biology, science of medicine, veterinary science, fisheries, forestry, horticulture, aquaculture, agriculture, poultry. These are the advanced applied research. Next. If you take biology, different fields is there. First, a main group of living things. There you can see bacteriology, microbiology, other than bacteria, everything is taken in microbiology, zoology. Structure and function, there morphology, physiology, histology. Changes and development, there you can see genetic, embryology, evolution, applied biology, biotechnology, and pharmacy. And living things, the environment, ecology, environmental biology, and science of biogeochemical sector. And what is the scientific method while designing a project you have to follow? Different methods they have given. Observation. First, observation is a key for science project. When you are designing a science project, observation is a key, plays a key role there. It is based on the curiosity and desire to explore world around us. It could include all human sense. It could be through technical device and equipment. It could be quantitative, qualitative, but scientifically unusual like qualitative measurement, they are precious. Next question or problem. When you are designing a project, their hypothesis should be there. Your question or problem should be there. Usually, observation is the research question or problem that require further investigation. If you are designing some work, what is your question. What is your hypothesis? Based on that, you have to design your project. Then hypothesis. Hypothesis should be right before performing the experiment. Before starting the experiment, you have to fix your hypothesis. This is my goal, and I want to check whether this result is correct or not. This is your hypothesis. Based on this, you will design your research project. Next slide. And plan for an experiment. The experiment should be like this: do background knowledge and review the published material related to your question. First, you are fixing some hypothesis, or you are going to work on some work you want to design. First, you start doing investigation on already published work. Example: we want to develop some tissue-like structure from cells. To go for literature collection. Who has already worked on this? You have to collect the entire data. You go for literature review. Then you can plan your work. Why? Because sometimes you will design some work. You have completed the work. Why? Going for literature review or paper writing, that time already that work is someone published. Then what you are working, it is a duplicate work. You cannot present anywhere or you cannot publish anywhere. So literature review or background knowledge should be considered. Then design a project experiment to test the hypothesis. While you are designing your project work, you have to fix hypothesis. Whether it is accepting your hypothesis or not, you have to fix some hypothesis. Then designing an experiment with the permit applicable evaluation of hypothesis. It is important one variable is changed. If you are doing some work in first attempt, you change one variable and keep all the other variable constant. Then make experiment control. The experiment should be made as a control. You are designing one experiment. You want to check the toxic effect of some pollutant or some pesticide. That time, what you have to design the work, complete work should come under one rule. Or you have to complete the work at correct time. Example, we want to check the toxicity of some pollutant. We'll keep 3 fish tank as control. Just we'll keep the water. 3 tanks will keep as the positive control. There we will add some known pesticide or some known chemical which will kill 50% of the fish in 96 hours. And then you are taking some pollutant, you take 5 concentration, these should be in triplicate. Like this, you have to fix 21 tank work should be complete at the same time. No, sir, we don't have a tank. We have just 6 tanks. We are keeping 6 tanks now. We will do 2 concentration control and positive control. Other experiment, after completing this, we will do other experiment. We should not do the experiment like this. We want to complete the experiment under one control condition. If you want to perform like this one experiment, you have to keep 21 tanks at a time. While doing research, usually the research should be then triplicate, 3 repeat or 5 repeat. If you want accurate result, you go for maximum number of repeat. Usually you can go for 8 repeat also, you will get accurate result. Then include the precious way of measuring the result, collect more data and verify your result. While this was I explained, if you want to do triplicate, you will get accurate result. If you want to do 5 times or 6 times, 8 times, you will get accurate result. So experiment should be repeat and you should get the consequent result. Then right step you will follow your experiment. What are the steps you are going to follow for your experiment that you have to write in your log note. Before starting your experiment, you have to write the experiment what you want to perform. Conducting an experiment. Before conducting experiment, just you go through literature review. After collecting literature review, no one is work on our experimental design. You go for some methodology. What are the methodology you are going to follow that you have to plan. Based on that, you have to design your work. Next slide. While designing work, it should be objective, then introduction, materials method. In objective, what you want to do, what is your aim that you want to design your research work. That objective should be that introduction. You go through the literature review and give everything about the background knowledge. It will come under the introduction. And materials method. What are the methods you want to follow in your experimental design? It should be come in the materials method section. Then you go for the result. Result includes data analysis. What was the data you got from the your experimental design? It should become in the result section. Organize the data in the form of photo, graph, chart, tables, etc. Then conclusion. The entire work should be given in, as a conclusion with not more than 5-6 lines. It should be complete in one para. That should be 5 to 7 lines. If you're going for a literature review, you will get 3 different types of papers. First, original research article. When going for literature review, you have to go through the original research article or review article. The research article, it is called as full paper. If you take the research article, there will be a title, author name, abstract, introduction, materials method, result, discussion, summary, and reference or bibliography will be there in the research article. If you take short research article, it will be around 10 to 20 page, or sometimes it will be 30 page. The writing will be, should contain around 4,000 to 6,000 words in the research article. If you are taking short communication, your work you can publish as a short communication, not more than 4 typed page. There should be around 2 to 3 figures or 2 to 3 tables should be there. It is called short communication or brief communication or report. And review article. For review article, if you take someone is working on some pollutant, if you take one review article, they will consider all the paper which is work on pollutant. It will be there in the review article. If you want to design your work, first you go through review paper. There you will get the background knowledge of your research design. And a paper, it will be like this. If you take a research paper, this research paper will be like this. Paper title, the title should be summarize your work. Keep it short and clear. You should impress the reviewer or journal so that they will take your paper for reviewing and then publishing. That's the title, paper title. Then table content. What are the content is there in your paper? They should be come to see table content and abstract. Abstract is an important part of the research paper. The abstract should be not more than 150 to 250 words and keywords. Keyword should give 4 to 6 keywords. That keyword should be there. What are the main part of your research? From there you can take 4 to 6 keywords. Then introduction. Already you have gone through the literature. From that literature review, you have to give your introduction. At last, you can give your question. What you want to solve? Which problem you want to solve? What is your goal? That you can give in the introduction at last. Then materials method. What are the methods you are going to implement in your research work? That should be come in the materials method. Materials method, some data, some already work published. From there, you are going to take the materials method. With that, some small changes will be there in your experimental research. Next. Then result. Result includes the data analysis present in the form of chart, table, graph, etc. It should be in the form of chart, graph, table, and some return. And discussion. In the discussion part, what the result you got and what the result other people, other already published papers they got. You have to compare here in the research section. Then conclusion. In conclusion, the entire research work should be discussed here in a 5 to 7 line. And acknowledgement. Who are the people work on this paper and who has been helped in this paper? We have to acknowledge. Sometimes institute, sometimes some individual. They have some contribution in our paper. We have to acknowledge, and then finally reference. Reference should be there in the research paper. Now, before designing your work, this was the news recently we got last week. You are not supposed to use any animal in the school or college. If you want to use any animal or example, now you cannot use fishes also. Government will stop using animal in the experiment research. So what they are planning for some alternative method. You should not use directly. You should not use animal. If you want to work with some animal institutional animal ethical committee is there. If the institutional animal ethical committee, you have to get the permission. You have to present your work. What is your research design? You have to show your research design. Based on that, how much animal is required for your research. That the institutional animal ethical committee they have to approve. In that institutional animal ethical committee, one veterinarian is there. He will give how to kill the animal. You have to follow all that guidelines. Then you can perform your experiment. Next slide. For that reason, forms and formats is there. Before designing your work, you want to work on some animal, you want to use some mice, rabbit, like this. Here, number of forms and formats is there. You have to go through this forms and formats. If you want to work with some human, how to collect the human sample, how to process the human sample, then how to discard the human sample. It will come under the form and format. Or you want to work with some animal, how to kill the animal, how to maintain the animal. Everything will be there in the forms and format. You have to get the clearance with this forms and format, then you have to design your work. The research paper will be like this. The top biological trace element, it is the journal name. If you see, it is linked. Below that link, it is a research paper or full research article. And the title, author's name, abstract, keyword, introduction, and so on. It will go materials method, research discussion, and summary, bibliography, etc. Next slide. And how to present the display board in the science fair. The display board should come like this. It should contain a title and question. What is your question? What is your problem you want to solve? It should be there in abstract and hypothesis. Here what we have given this our own result we have given. Here what the title is development and characterization of primary cell line from the spinal cord of HMC cord. This was our title. Based on this title, we want to work and no spinal cord cell line were available in the world from this fish. Before that, we collect the literature. We plan to develop the cells from the spinal cord of this fish. This was our question, and we have given the abstract. What the entire research was carried out. That we have given the abstract. Hypothesis. What is our hypothesis here? To develop and characterize the neuron-like cells from the brain. This was our hypothesis. Based on this hypothesis, we have designed our project board. The project board should be there like this. Title, question, abstract, hypothesis, procedure or materials method, result, conclusion, and finally acknowledgement. Next slide. These are the other examples for the project board. Next slide. Here what we plan one small research with the bubbles. We use that bubbles for our research. The student will play with some bubbles, water bubbles. If they put the bubbles in the water, it will swell. Usually what people used to do, instead of using this bubble, they will use some micro carrier. That micro carrier, it costs around 25 grams, it costs around 1 lakh rupees. Here we use that the children play with that small bubbles. We use the bubbles here that the people what they are using micro carrier. This the bubble cost around 180 rupees, 25 grams, and that the micro carrier it cost around 1 lakh rupees, 25 grams. We use these bubbles instead of that micro carrier. It is working. This was our aim here. This was our hypothesis whether this bubble is suitable for culture tissue over the bubble. This was the hypothesis we fixed, and it is working. If you see that bubble.
First leg.
Artificial laboratory condition, we culture the tissue, we culture the cells over the bubble. This bubble supports what the microcarrier supports. It is working like this. That the microcarrier it costs around 1 lakh rupees. What we use it is around 180 rupees. Like this, you have to design your work. Some novelty should be there in your research design. Other areas, how you can design your biological research, different topic already they have published. Like this, you can design your research work, effect of light on the temperature of bacteria and algal probe. Like this, different topic you have given. By this topic, you can design your research work. And for the presentation, we have to prepare the student like this. We have to follow this. They have to dress up professionally with appropriate decent dress. Then be polite and pleasant, cheerful. Then speak. Ask them to speak louder and clear. Then avoid verbal cluster. Do not use chewing gum or candy. They should stand over the side of the display, and they have to introduce themselves before presenting their work. Then ask to present, keep the eye-to-eye contact with the judge, and then open the presentation interesting statement with some question and explain little bit the idea your project originated, and make sure your research subject research thoroughly background information. That the literature review should be that clearly. Next. For evaluation of the project presentation, how they will give the mark. Like this, for the research question and problem, we'll fix 10 mark. Design and methodology, we'll fix 15 mark. Then the data collection, analysis, and interpretation, 20 mark. Creativity and innovation, we'll fix 20 mark. Then for poster and interview, we'll give like this mark, and the mark will be given based on the performance. Next. This is about our laboratory. After lunch, if you want, you can visit our lab. This is the facility available in our aquatic animal health laboratory. Sir is the director. We will get the permission. After lunch, if you want, you can visit the lab. This is the cell line we are maintaining in our lab. If you have any questions,
Where your lab is.
the campus you can ask how sir like everyone is there. The campus you can after lunch you can ask Shahul sir lab, you can visit the lab.
हाँ अच्छा सर हाँ होगा खत्म होगा
Assalamu alaikum and very good afternoon for one and all. Already the time is running too short.
செவிக்கு உணவில்லாத போது இந்த வயிற்றுக்கும் ஈயப்படும் என்றான் பாரதி. ஆனால் செவிக்கு சரியான செமத்தியான உணவை வாங்கி அமர்ந்திருக்கிறீர்கள். உங்கள் வயிற்றுக்கும் அறுசுவை உணவை அப்துல் ஹக்கீம் கல்லூரி நிர்வாகம் ஏற்பாடு செய்திருக்கிறது. நான் நீண்ட நேரம் எடுத்துக்கொள்ள மாட்டேன். தமிழக முஸ்லிம் கல்வி நிறுவனங்களின் சங்கங்களின் கூட்டமைப்பான ஓவியத்தும் தன்னாட்சி அந்தஸ்து பெற்ற மேல்விசாரம் சி அப்துல் ஹக்கீம் கலை அறிவியல் கல்லூரியும் இணைந்து நடத்திய அறிவியல் ஆராய்ச்சி பூர்வமான கண்காட்சிக்கான ஏற்பாடுகளை செய்வதற்கு மாணவர்களை தயார்படுத்துவதற்கான பயிற்சி பட்டறையினை இணைந்து நடத்தியுள்ளது. பள்ளி ஆசிரியர்களும் கல்லூரி பேராசிரியரும் கலந்து கொண்டு இன்ஷால்லா எதிர்வரும் செப்டம்பர் இறுதி வாரத்தில் நடைபெற இருக்கிற நேஷனல் சயின்ஸ் ஃபேர் 2025 ஓவியத் அண்ட் அப்துல் ஹக்கீம் கல்லூரி அதில் உங்களோட மாணாக்கர்களை பங்கு பெற வைத்து அனுபவத்தை கேட்டிருப்பீர்கள். ஒரு என்எஸ்எஃப்பில் பங்கு பெற்று தோல்வியடைந்து 4 வருடங்களுக்கு பிறகு அடுத்த என்எஸ்எஃப்பில் பங்கு பெற்று வெற்றி அடைந்து அதற்கு பிறகு சைனாவில் உள்ள சயின்ஸ் ஃபேரில் வெற்றி பெற்று மருத்துவம் படிக்கின்ற வெளிநாடுகளில் படிக்கின்ற ஒரு அனுபவத்தை அதனுடைய ஆசிரியரே உங்களுடைய ரிசோர்ஸ் பர்சனாக என்று கண்டீர்கள். ஸோ அதுபோல உங்களுடைய பிள்ளைகளை வளர்க்க வேண்டும் என்று வாழ்த்தியவனாக I would like to express my heartfelt thanks to one and all from the administration, office bearers and staff of the C. Abdul Haqim College and our office bearers of OMIA and our staff, especially our chief guest, Dr. Qasir Azhar, who come over from USA, and the backbone of the NSF project of OMIA, Dr. Imam Abdul Kamal Nazar, and the correspondent secretary of this college and who is the vice president of our OMIA, Dr. Ziaud Sahib, and Sajid sir, and other office bearers, administrators, everybody. I'm extending again my heartfelt thanks to one and all. Thank you. Jazakallah khaira.
Thank you, sir. We warmly invite all our respected guests, resource persons and participants to kindly proceed for lunch, which is arranged at R.